Moscow Python возвращается после принудительного проветривания. Нам это пригодится, потому что сейчас
the mandatory breath of fresh air. I think it's quite useful. Let me invite Yulia Volkova on stage. Gents,
сейчас
if your brain was blown by Vasya, now you will have some soothing relief.
Простите уж.
Do forgive me, guys. Can you hear me well? Hi.
Я думаю, что сейчас мы вернемся к бизнес-задачам.
I believe that now we'll go back to business tasks.
Не думая о теории.
Simple tools, don't think about the math. Some math, just a little bit. Significantly more lightweight than it used to be. We'll talk about syntactic tools to analyze in today's development. We will not be talking about interpreters. Surprisingly, who am I? Here's my GitHub. I love meta-programming, syntactic parsers, generators, ASC, that's my hobby. However, syntactic analyzer is the part of my work that somehow got to my professional life. All of a sudden, I put that in production. I did not even expect that to happen. So what are these things? And the clicker died. Okay. We'll talk about business tasks, what it is, what should we begin with, what libraries there are in Python, how they're different, what can we pay attention to when we select a tool, and we'll look at a few code examples. I wanted to make a live demo if we have the time. Business tasks. For about 5 or 7 years, we've been living in the data world, where most of the assignments are around data. So this is from Snowflake, but it's not a secret to you that most of the analysts in most companies have the data warehouses. Somebody uses cloud solutions, normally solutions made for the analysts so that they would be writing SQL queries and be happy to use the data. So those people who support that kind of stuff experience a few problems. We don't want to give the analysts the opportunity to write whatever. Analysts don't need that. They want hints, highlights. They want syntax errors to be highlighted. They want to see optimized queries. We want to show more optimal tables to select data. Dear friend, don't do this 2000th view of this table, which you want to grab. We want to do that. So how do we analyze that? We understand that our query is a text, an input. You've seen SQL. Python, you know it, just a text which we can analyze. Next, we have more exciting and complex tasks for validation. Data warehouse is usually a ton of tables. It's not like we have 4 tables of data or 5 tables of data. That's 2,000 tables. We don't know who wrote those tables. We don't control anybody who's using those tables, but we control the entire cluster. Seems cool. We have tables with dependencies, and then PR is coming and says, let's just delete this table, and we cannot track that manually. When the analysts are giving us 300 PRs a day, we cannot just manually check whether we can delete this table or not. Then somebody comes and says, guys, I want to add another column that will be taking data from this table. We're saying, cool, but what will happen? Will we get some kind of recursion or not? And there are a lot of questions like this. Can we delete the table? Can we delete the column? Can we add a dependency? Can we give a person an opportunity to do what a person wants? Maybe he's doing some UDF that's curling some personal data, and they do whatever with that, and a security will run and scream, why? So we can use syntactic analysis for that, because we cannot go to the storage and look at every single table. We have some notion of DDL and we work with that. And that's what we can analyze. So, but that's not it. Data. Cool. We have a ton of products, a ton of startups that are making cloud calculators, accounting solutions. They have some formulas. Formulas and parsing and analysis of what the hell is that, whether it's valid or not. It's one of the things that syntactic analyzers do. And, of course, query languages. languages. This is a screen from Jira. Probably you know what this is when you write a query, and it gives you according to your request. A lot of companies do this custom analytics solutions, task managers with different query languages. So, how do we analyze and understand this? We need syntactic analyzers for that too. Also, we can swoop into there a lot of different tasks. Mostly, we talk about linters, any kind of transpile from one format to the other, so that we convert something from one format into the other. First, we need to understand what's there in the beginning. We need to unparse that thing. And as a matter of fact, syntactic analysis is applied to any text input, any data. If you want to find the command, some pieces, these are all tasks for syntactic analysis. And then, of course, compilers and interpreters, a classic example, telling you about what tokenization is.
Про то, что такое у нас лексический анализ, лексический анализ, соответственно, мы слышали в докладе до этого, что есть
analysis, lexicographic analysis. We know that there is this thing in Python. We take the source code, we break it apart into tokens, and then those tokens are put into the sequence of some kind of syntactic instructions, and we understand whether it's valid or not, and we build the AST tree. What's the complication of working with parsers? For example, you sit down and you write a backend, and you're writing code for data engineering. And then you think, okay, I need to unparse something. And then it begins. Terminals, non-terminals, LL, BNF, EBNF. All of these acronyms on your screen. And it's falling up on you.
Где вот там берешь любую цитату из середины, они, например, выглядят как вот эта фраза «левая рекурсия», что-то там, произвольный строй.
You know, left recursion, something like there. Like, how do you talk about complex things in a simple way? No, not like this. My presentation is about that you don't need to know this thing. When you interview the mids or the Junes who are saying, I've been writing 2 years in Django. Okay, tell me about HTTP protocol. He's saying, I don't know. Wait. But you're writing backend. Yeah, I do, successfully. So if you need to write parsers, you don't need to understand all of this. Okay, you need to do and know fundamental things. And that's what I'm going to be talking about. But a notion. This thing, the syntactic analysis of the parser, it's been born back when the first compilers were born. So there will be a little of theory right now. Don't get asleep. There is Noam Chomsky, a person that is coming up from time to time, the formal language theory. If you go into the depths of the parsers, you will find the name of Noam and the syntactic analysis as well. Noam Chomsky is a linguist by training, and his specialization was natural languages. First, he did make the grammar classification for the formal languages, but if you don't know what formal language is, I will tell you later. It was all based on actually natural languages, people who have been writing the first meta languages to talk about grammar, like BNF. We'll talk about that. Don't be afraid. All of those people who were writing the first top-tier programming languages. Bekas, Fortran, Naur, who was creating Algol 60. So the mission of syntactic analysis, first and foremost, was stimulated by the programming languages. And please pay attention to that tag that we're talking about a lot. It came up and it was boosted in 2004. I mean, in relation to EBNF grammar, that's quite a fresh thing. In addition, PEP is not falling into Chomsky classification. All right, if we look just at a little bit of theory, we see that every language has a set of symbols, alphabet, and of course, kind of the rules for making expressions. That's grammar. Syntactic parser is a tool that is being used for the analysis of the texts, for natural languages. That would be the NLP presentation. Or we will be talking about formal languages. Syntactic parsers are used to identify the structured languages and define connections between elements. I'm sorry for reading a slide But it's the shortest, simplest way to say this. What is grammar if we look at this thing? As a matter of fact, this is a kind of meta-language to describe the structure, meaning that we're talking about BNF notation. In the corner, you can see that. We're saying that there's a kind of an expression that consists of sub-expression, like a token expression. And every token is non-terminal that we describe. So in the first slides, we have seen this expressions terminal, non-terminal. It's easy here. This is one symbol, A, B, C, letter, whatever. SC, that by default is a symbol that we're using. And non-terminal is any combination of those symbols. That can be like a token, a word, a brief word. If we recall SQL, we have this token called select. That's a token that has a particular function, role. Or non-terminal can be the entire expression, like here. Primary is by power of the factor. That's non-terminal yet, although it does consist of a few tokens. All right. Let's continue. The formal languages theory is a science in itself. So why are we using these classifiers? How do we parse them? How the parsers work? It's all within the theory of formal languages. So we will admit that. We do remember that we need to solve business tasks. We don't have the time to get a PhD on this. We need to actually release features. So let's look at the example. Think that you are working for the company and your analysts are writing SQL well, and your managers come and say, we don't want to write this queries. We want just to input the name of the table and tell, we want this. This is the request from business analysts. Okay. On the left, we have the table name. On the right, we have some data that we want to get. And the managers don't want to write this queries, just sort of text-based request. We understand that for the backend, the thing is that this input must be transferred into some kind of select, right? Select from clients, etc. And before we make it happen, we do a few actions. We need to unparse our code and understand what happened there. We need to get something, and from that something we want to generate our SQL request. So, if the generation of the code is not about our presentation, then today we're speaking about how we can unparse this thing and how we can get something out of it. For example, abstract syntactic tree. As a matter of fact, this is not a mandatory output of syntactic parser. I have here a few personal examples on why AST is good and why we don't need to try to make some output like generate query at the output. If we have the time, I will show it to you, the horror without AST. Next, we look at the inputs and saying, oh yeah, it's simple. We have some value here, we will write something regular here, and it will be fine. Then the business analysts come next day and say, dudes, we have thought that it's not one table, but some iterations. Like, we want to see some intersections between tables, or we want to make some exceptions, so we would only see pushes from the order. And the managers are saying that everybody wants this syntaxes. All right, we are saying, let's adapt to that. You adapt to that, and that's some kind of value with some operands in the middle. And then the analysts are saying, yeah, we want to have a data range for that as well. You're saying, all right. So it turns out that's the entire grammar there, which needs to define what is a valid input and what isn't. Grammar is a set of rules that says, guys, this line on the left is okay, we know what to do with it, we know how to work with it, and this heresy on the right is not valid. We need to drop syntax error and say, guys, please rewrite this one. And before I continue telling you about the toolkits, about how it's easy to take and use the parser, let me draw your attention to a very subjective notion. First of all, ready-made solution in terms of parser is always better than something that you write on your own. Dealing with somebody's parser that somehow works is much easier than writing from the ground up. Build the transformers. We'll talk about transformers a bit later. And the worst is that not that you have unique grammar like in my synthetic example, but for example, you want to support the redshift dialog. Do you want to use the redshift, but you need to validate SQL query, and there is no parser in Python for that. You're thinking, I'm going to write my own. Congratulations. Even DDL, data definition language, if you don't know this, it's not query with the select when you write create table. When we just just announce our data, declare our data. That's a lot of grammar, which is hard to support and maintain. And it has a lot of variability. So next, before we pick parse the library, surprisingly, we need to be looking at a lot of things, like how does the definition of grammar look like? How transformers AST look like? And with the case of parsers, it's kind of I'm just gonna go and grab what has more stars and most downloadable, and it doesn't work because it may have stars because it's just very, very old, but not because it's just really good or works well or fits well. Next, always bear in mind that the code that you're writing is not your personal property. Even if you're so awesome and you've been working in a company for 4 years, you don't want to support this parser for 8 years and maintain it. You will transfer it eventually. Syntactic analyzers is a very special kind of thing. 99% probability is that there will be a person who will come to replace you, and that person will know nothing at all when you write parser. Bear that in mind. Most of the people who are writing parser for work-related projects never had experience of working with parsers before that. So if you do something, please describe the logic of why this thing is here, why the transformers are like that, etc. And better cover those with tests. So AST, abstract syntactic tree, is always a result of parser's work. It's more understandable. Single responsibilities in parsers works very, very well. Don't make a parser that at the output will generate you the code right away and making a cat out of the dog, because when you will need to be able an elephant out of this, it will be much harder to maintain your code. So initially you make the AST, and then you take that AST and you do code generation, any kinds of entertainment which you want. And yeah, often they ask me, why? Why do you need parser generator if you can make a few regulars? If it's enough for you, love it. You don't need a parser, indeed. You just need a couple of regulators. Yep. A couple of regulars. As for grammar, this is a slide with a hint. There's this very old parse generator, Antler, with a lot of grammar written on it. Python, Swift, Java, ton of SQL dialects. The disadvantage of this parser is that it has very specific grammar. For LL grammar, there are no active tools for parser. Only Angular is working with that. But you can rewrite it, convert it into some new format. Much easier than trying to sit down and write it manually. Next, I mentioned already parser generators. Again, very often people who have never faced syntactic analysis begin to get confused here. What's the difference between parser and parser generator? What's a parser generator? That's a library that is made so that it would be easier for you to create a parser. It has all of the algorithms implemented in it. It has the grammar reading in it. Parser generator is telling you, friend, just write me the grammar and the transformer, and I will make a parser for you. And parser is the actual software code that analyzes the actual grammar. It's created for particular goals. So, simply, parser is everything that you faced and worked with. YAML, XML, config parser, SQL parser, everything that can sort of identify your text and give you some output. With parser generators are libraries. When you go to the page, you see all of these terrible acronyms. BNF, EBNF, on the left you see. Parser generators are only in Python. Only in Python. There's a repo with the examples of different codes for different parser generators. Only Python libraries, there are about 16, which are actively supported. The libraries that have some chunks of code. So, you can take a look at the full list and take a look at what's interesting here. They're all different. That's interesting. They have different grammar and different parsing algorithms. These libraries are written not because people don't have much stuff to do in the world. Everybody decided to implement their own parser generator just because they implement different types and versions of algorithms. Different algorithms of how it's possible to make grammar and how it's possible to work with that grammar. And yet again, having reminded you about regulars, config parsers, these parser generators are easily using regex. In the example, I will be talking about 4 libraries. On the left, you see the list, and I will use them as an example to show how different parser generator can be, how different the code can be. Now, a few words about grammar. We see here things like EB and F. What types of grammar there are for the time being. If you ever work with syntactic analysis, you will be constantly encountering 2 terms: context-independent, context-agnostic, and parsing expression grammar. The first ones were created at the age of Fortran and Algol, etc. Well, described, not created. So why we have PEG back? What was the idea? There's a beautiful article by Sam Ford, but context CFGs, they were created bearing in mind natural languages. And when you read the grammar cannot clearly say how a particular language will be parsed. The process of parsing is strongly dependent on the algorithm of implementation. So PEG grammar is kind of with one meaning. No matter who wrote this, when you read PEG grammar, you always understand how tokens are being read, how they are put into input, and how we get the output. PEG simplifies syntax. It actually removes the need for the first tokenization step and separating linguistic and syntactic analysis. Linguistic when we're looking for tokens in our texts. There is no separation for hierarchical components. And when we see BNF, EBNF, LLK, we can continue the list. All of these are forms to describe the context of free grammar. How in our syntax, what language we use to describe what's valid for our language and what is not. So if we compare extended form, which came up to be later, and it's the continuation of BNF, we see that EB and F is much easier and significantly smaller. While there are well-known operators like a question mark or a plus, which are saying us if we, for example, have a particular figure here, like a number, an integer, there can be a minus next to this number. Or it can be a point or a float, and some numbers after the float. We see that our numbers can be floats or integers. So BNF is much heavier. It requires much more effort to describe. If we speak about PEG and BNF, syntactically, they're very similar. There are some differences to them. And if you enter the Python page with the grammar description, you will see that Python tells you we're using a mix between EBNF and PEG. And that's a very important point because this mix is being used by many parser generators. We will talk about that a bit later. Parser generator is a piece of software that somebody's writing. Those who write it can put any changes into the notation, and as a rule, nobody supports pure RFC regarding grammar. Okay, all right. If we take a look at the comparison of the extended BNF and PEG, we'll see this operator, this backslash that says that there is a certain sequence of search. In the case of extended, Bacchus and form, we don't have some kind of sequence of search. Here we can have either string or float or date range or int, and then it all depends on how the algorithm is implemented. If the algorithm is implemented from left to right, then whatever is found from left to right will be the sequence. If it's from right to left, then it's a vice versa. So when we read EB and F, we don't know anything about how actually, at which which point the parser will stop and say, I found this. So working with the BNF, we need to understand what kind of algorithm is actually active. And accordingly, for eBNF grammar, there is this shift-reduced conflict thing, which I just mentioned. Depending on the algorithm, parser can interpret our input differently depending on the grammar, and the same grammar can work differently for different algorithms. Also, PEG has extra expressions which do not include eBNF grammar. That's a disadvantage. The minus here that's telling us, for this expression, we admit not terminal A, but without terminal B. So we're saying that B is a kind of a non-terminal of the word mother, and at a certain point, at a certain line, we want to use whatever, but there's no mama, only like grandfather and grandmother. It's quite convenient with PG. A few words about algorithms, briefly. As I said, there are a lot of them, and for all of them, there are research articles. People write PhDs, invent new optimization algorithms. There's an advantage that if you try to solve business tasks, you don't need to understand anything about these things. You need to know that this thing exists, that this thing is being used in this library, and you need to look with your eyes at how your grammar works with this particular parser. If you're not writing your parser generator, then you don't need to understand how these algorithms work. Therefore, knowing the algorithm, only working with parser generators, which work with eBNF grammar, you need to understand just to know whether your token should be on the left or on the right in the grammar. You can reuse it recursively, I mean tokens recursively or not. For that, you need to understand the algorithm, but you should just play with it. So, what do we want to do? We want to unparse all of this. And before we look at the code, if we look at the code, let's talk what's the code for parser generator and how does it look like. This is a Parsiminia's library. As a matter of fact, it's similar for all of the 16 Python libraries. It may be called a little bit different. The transformers may be called a bit differently, but as a matter of fact, you need to describe the grammar. So the grammar, depending on what kind of format of grammar is supported by the parser. This is a PEG example. Well, let's not be picky about the naming. This is not good naming for grammar, but we see here that there is some kind of key expression that was on the left, and there's some kind of value expression, and in the beginning of every piece of grammar, we describe the entry point, this line in PEG grammar. It says that we are starting from the top, and we're looking for all of the places where a key expression and column coincide, or a value expression. And then the parser is trying to build a tree and find out what is key expression. And then it goes down, and if in this code we put our line somewhere below or a value higher than the value expression, this thing will just fall apart and the parser will not work. So we feed our parser generator with the grammar, that's why it was created, and then we build our visitors. Or somewhere it's a visitor, somewhere it's a listener. I mean, roughly speaking, as a matter of fact, that's the processor that's either processing input nodes or does something else. So it's hitting the output of our parser saying, okay, if you go to this expression, non-terminal line, then please do this. Or if you encounter K, then do that. As a matter of fact, it's something like passing down the AST nodes. So in different libraries, that could be called differently. Some were visitors, some were listeners, but more or less, this is the same thing. You describe this class. Then you do whatever you want. You call a parser, you call a visitor that you've just written, and then you work with the result. For Parsiminias, this is how a parser looks like. It doesn't not generate any files or code, it just runs in runtime, creates a parser, and it works.
Соответственно, для парсер-генератора, для того,
So for
чтобы
parser generator,
сделать наш синтаксический
in
анализатор,
order
вам нужно
to
только
do our
грамматику написать,
syntactic analyzer, you need to
правила
just describe
языка,
the
и нужно
grammar
вот написать
with the rules
обработчик,
of the
который
language
будет брать
and
каждый
write the processor that will
нетерминал
be
и говорить, что с ним делать.
take every
Присваивать какой-то
non-terminal
AST-ноду,
and do
либо
something
же
about it.
там какой-то другой
Either
выход,
assigning
который вы
AST
хотите.
node or any other output that you
Теперь
want.
посмотрим на инструменты.
Now,
На примере вот
let's look
тех
at
4
tools
библиотек,
based on the
про
4
которые я говорила.
libraries that
Допустим,
I was
если мы
talking about.
возьмем
For example, if we
мы
take
увидим, что
Antler,
мало того, что у нас какая-то специфическая грамматика работает,
it's not only that it has some kind of special grammar,
работает с этим алгоритмом.
also
На самом деле,
there's the
в этом
algorithm
плане,
there. And
он
actually,
довольно редкий. То есть
it's quite a
грамматику
rare thing.
мало кто использует. В чем плюс
Not many use
Antler?
its grammar.
Во-первых,
What's the
потому
advantage
что
of
на нем очень
Antler?
большое количество
First of all,
грамматик, он генерирует
there are a lot of grammars
языки,
based on it.
он
It
генерирует
generates
парсеры на разных
languages,
языковых
parsers
языках,
for
там у
different
него есть
languages,
поддержка
including
Java,
Python.
поддержка
It supports
JavaScript
Java,
и других
it supports
языков.
JavaScript and other languages.
Ну и есть, да, готовое количество грамматик. На самом деле,
And of course,
достаточно
if you
сделать
ready-made
install
grammars,
tools, ну, еще
you can just
установить
make the
JVM
pip
для этого.
install and
Потом
install
на основе
GVM for that,
грамматики,
GVM.
которую вы создадите,
And then based on the grammar that you
Antler
create,
сделает вам парсер. То есть вам по
Antler
факту
will
для
make a
него нужно
parser
написать
for
только
you.
грамматику валидную.
So you
Больше
just
вы
need to
ничего
write
не
valid
делаете
grammar
с ним.
for it, and that's it.
Есть у него всякие
It also
приколы,
has
какие-то
different
нюансы
kind of
плюс. То
fine
есть,
things.
как я уже сказала,
Details,
парсер-генераторы пишутся какими-то
caveats,
разработчиками людьми. Они
donuts.
сами решают,
So
что
some
удобно,
people
что
are
неудобно,
writing a
что надо
parser
добавить.
generator, and they
В
decide
Antler
what's
есть, например,
convenient,
такая
what's
штука,
not.
как
In
фрагменты. Когда
Antler,
вы
there's this thing
можете
called
всю
fragments,
грамматику,
where
вот
you
если,
can
допустим, Parsimenius
take
мы
all of
смотрели
the
всё, что
grammar.
вы
If,
там
for example, for
описали,
Parsimenius,
оно
we were
там
looking at
есть, оно
everything that
там
you described,
разбивается на такие
it's
терминалы,
there.
токены, а в
It's
Antler вы можете
being
сказать, что
broken
это
apart
как
into
кусочек,
tokens,
это
terminals.
просто
In
фрагмент.
Antler, you
Он
can
не
say
должен
this
быть
piece is
никаким
just a
токеном.
fragment. It's
Парсер
not
его не
supposed to
должен
be some kind
распознать,
of
но вы
token.
потом можете этот
Parser is not
фрагмент
supposed to
использовать
recognize it,
как
but you
часть
can use this
какого-то
fragment later on
другого
as a
токена,
part of
какой-то
any other
синтаксической
token
конструкции.
or other
Есть
syntactic
разные
construction.
штуки, например,
There
как
are different
альтернативный
things like
лейблинг.
alternative
Это
labeling.
когда вы пишете грамматику,
This is when
и
you kind of
прям
write the
дальше
grammar,
через комментарии
and
пишете, что вот это
through the
будет
comments you're
называться
writing like this.
а вот это
This will be
break, а
called
это вы
return,
будете API.
and
И
this
дальше
will
вы
be called
просто,
break. This will
грубо
be
говоря,
called
вы
multi
именуете ваши
API, and you name
экспрессионы. При этом,
your
смотрите, у вас,
expressions.
допустим,
And
в
look,
примере stat и e,
in the example,
оно вроде как expression в грамматике, и там
this
нет
looks like an
никаких отдельных
expression,
токенов, нет
and there are
никаких
no
терминалов,
particular
но
tokens or
через
terminals in there. But
коммент, через комментарии
through the
символы вы можете
comments,
указать, что на самом деле это разные
you can
конструкции,
highlight
и
that
я хочу с
actually
ними
these
делать
are
что-то
different
разное. Эти
constructions,
ноды
and I
другие
want to do
присваивать. Это
something
тоже
special
удобно,
with
потому что
them.
грамматику
Assign
становится
notes to
меньше,
them, for
и
example.
надо
That's
для
convenient
каждой
because you get less
грамматики
grammar.
объявлять имя и
You
терминал.
don't need to assign the name of the
Вот
terminal
такая
for every piece
фишка
of
опять для
grammar.
Antler.
That's a thing for Antler.
Дальше, допустим, возьем питоновский парсер
Let's look at the
Lark. Он
Python
достаточно старый
parser
тоже, он
generator
поддерживает
Lark.
EBNF
Quite an
грамматику
old one. It
и работает
supports
с алгоритмами с двумя
both
SDR и с Lark.
EBNF
Причем,
grammar, and it
если вы
works with
будете
two algorithms,
переключаться между
early
этими
and
алгоритмами,
Larl. And if you switch
скажет,
between
что
them,
вдруг нельзя. Они
Lark will
разные,
tell
и
you,
надо
no,
по-разному
dude, don't do
делать.
that. These are
Соответственно,
different
грамматика,
algorithms,
которая
and
у
you
вас
need different
написана
tokens. So the
для
grammar that's been written for a Lark,
все, я заговариваюсь с алгоритмом,
for
она не будет
a
работать для
Laller, it will not work for yearly. Also, Lark has a few caveats in the grammar. It creates automatically the AST tree for you. That's one of the cool things about it, and they're constantly mentioning it. And there are different features like built-in tokens, which are commonly used. So there are things simple to labeling when you can take only one expression, and then in a framework of that expression you can tell that's not a terminal, and I used to write that, but put this line into transformers like this method, and another line like minus method. So in the grammar, you can call these terminals differently and generate outputs, and it will be sort of the same transformer. Next, Parsimenius. I didn't know what to write about Parsimenius. I just copy-pasted what they write about themselves. It's really convenient. It supports PG grammar, and it's the easiest one to use. If you do some kind of analyzer where you can use PG as grammar, and if you want something fast and lightweight, Parsimenius is for you. Indeed, it's very convenient to use. I cannot say that it's the most convenient, as developers say, and everybody's constantly saying about benchmarks and performance. I have not been comparing this one. I didn't have any business tasks which I could test it on. Sometimes you develop syntactic analysis, you want to follow the performance. Normally, parsers are not so slow so that you want to test their speed and look at the benchmarks, profile, etc. Usually, a standard tool is enough. All right. Now, ply. Ply is a thing that comes up in a conversation about parsers, most often. And in my work projects, I see it again and again. This is one of the oldest parser generators, and unfortunately, I have a project written on it, one of my first parsers. I still drag on this one. I don't know when I will have the time and energy to rewrite it. Its main disadvantage is B and F grammar, which, as I've shown you, is significantly more massive than EB and F grammar. And in addition to that, Ply, for some reason, decided that grammar is easier to be described with functions, which are also visitors to that grammar. We shall look at that a bit later and discuss why that is bad. And as a matter of fact, Ply was just the port of C, Lex, and YACC Yak to Python. Ply is bad. That's my opinion, but I would not recommend. Let's compare the grammar. We have 34 seconds to do that. First, though, my screen is not showing. 5 minutes. Oh, I have 5 minutes. Cool. Sweet. Okay, let's make it happen then. Let's look at the Ply example. Let me show you Ply in the real project. I have this library called Simple DDL Parser. Naturally, a parser that supports a ton of different dialects. Oracle, MySQL, SQL, etc. Unfortunately, when I wrote it 5 years ago, nobody told me that grammar matters. And the parser itself matters. So how does this implementation of Ply look like? We have some methods which contain the description of the grammar. And every expression is the transform, meaning that we write down in the listener what we want in the output. That's an example of why you should not be doing any other output apart from AST. Imagine debugging this when you just have 2,000 lines of this. Of course, you can grab some methods out of it, but when your grammar is here and some kind of transformer, and it's not AST node, but just kind of some logic in here, this is really, really, really bad. But when you do this thing, you cannot stop, because every time you're saying, yeah, I will just add another syntax to it, and then I will refactor it tomorrow. No, you won't. If you look at the parsimonious, it looks much better. It lives separately. Parsers, transformers, that's a special kind of class. You can really separate it easily. And practically that's how it works and how it should be. In all of the other parser generators apart from Ply. Same with Lark. You first describe the grammar. There it is. You can, again, separate it. Lark has even its special format like .lark to support grammar. You can put it in a separate file if you feel like it. Here are the imports that I was talking about. Lark has tokens which you can reuse. You don't need to put certain things into your grammar. They are in the Lark already. Then you write a transformer that just produces some kind of output. In all of my examples, it's not the AST tree, just because these are synthetic examples generated by ChatGPT. By the way, they asked me not to put modern technologies into this one, but please do excuse me, guys. But the first obvious idea which comes into mind when you work with this kind of grammar is, which has been there for 50 years. You think, well, there is a huge kind of a data, and you can train a model. Actually, ChatGPT is pretty good at this mock-ups. Or like ducks that look like ducks, but do not quack like ducks. You can generate some code for parser. It even looks like it. It looks like the real code, but it doesn't work. You need to comb, you need to polish it up a little bit, but you have to. But it's really good at generating regulars.
Вот, соответственно, если говорить про Antler, допустим, как правило, описывается грамматика просто в G4 формате. Вот она выглядит, а дальше...
Antler describes grammar in a G4 format.
Сейчас я покажу, что происходит с Antler. Терминал только верну. Вы просто
So
берете,
you simply
делаете poetry shell,
do this poetry shell,
и говорите, друг
and
мой,
you say,
пожалуйста,
my dear
генерируй мне
friend,
парсер.
please generate me a parser.
Указываете мой файл откуда. И он вам нагенерировал
And it
миллион
generates
файлов.
you a billion
Собственно,
of
вот этот
files.
код, который исходный получается,
This is the
это как
code,
раз
the source
непосредственно
code
ваш
is
парсер,
actually
который вы
your
можете также
parser
завернуть в
that
build.
you can
Можете
put into
завернуть в
Vil
любой другой формат, который
or
хотите,
any
просто
other
вы будете
format
использовать,
that you
вызывать.
prefer, and
То
then
есть
use it,
Angular
call
для
it.
вас генерирует непосредственно код.
Antler generates for you the parser code.
Вот. Так, теперь мы сейчас вернемся на слайды обратно.
Let's go back to the slides.
Собственно, подводим итоги.
Let's
Выбирайте
sum up.
какой-то парсер-генератор, исходя из удобства.
You
написания,
select parser generator
Если
based on the
вам
convenience
не нужно поддерживать грамматику,
of
не надо
maintaining. If you don't need to support and maintain grammar, if you don't need if you don't need regulars, great. In 90% of cases, you don't need to understand how the algorithm works. You don't need to understand how this has been created, out of what. You don't need to be anxious about the large number of vocabulary items. Just use it.
Хорошо. Вы погрузитесь в теорию формальных языков. Парсер это не страшно.
You will get into the theory of formal languages if you want. Parser is not scary.
Почему вы что-то
Just
делаете?
leave the comments for your descendants. Why and what you have been doing.
Помним о том, что у нас любая работа парсера это какой-то
And
и что-то мы
any
подаем на выход. Возможно, вам
parser operation is a code with the output. So maybe you can just use some Rust parser or
импортировать в Python и как
JV parser and express that into
Что еще
Python.
посмотреть? На самом деле
Another thing to look at.
материалов есть в сети. Если вы
There are a lot of things to read on the web, but most of these things are kind of in-depth.
погружения есть разные хорошие статьи. Прям
There are different great
вот
articles.
хотим в формальные языки погрузиться, с чего начать?
You want to get into formal languages, here's what you start with. There are huge articles, really cool, with the parser generators. Actually, a lot of things written about that. You just need to know what to pick.
Поиграть спек грамматика онлайн. Есть
You can play with the PHE grammar online. There are online resources for that. It's on Java, but still, if you want to get to know PHE, that's good enough. As good as any. That's it.
Начинается конкурс вопросов.
Okay, now we have a question and answers competition.
вот здесь
There's Wonderkind at the row 1. Are you ready?
Ты просто умные
Your
вопросы
ass is a
задавал
wonderkind.
уже,
No,
а
I mean,
еще
you've been
у тебя
asking good
мерзкий
questions.
цвет волос. Так не
And also you
бывает.
have merged by the color of your hair. It doesn't happen every day. All right, as a matter of fact, I have one question. All of these parsers is quite cool and curious. Yeah, awesome. Every time the developers are looking at it, they run away. They escape, according to my experience. It's everywhere. When they use parser, they come to anything. Templates, regulars, whatever. Anything apart from parser. Can you name any real production cases when you really need this and you can write your parser? You do not take the parser of Python, SQL, but really need to write your very own. That syntax is for analysts, etc. Well, no. You go to the project, you arrive at the project, and people are telling you, we're using vertical for the database storage, and you will not find a single parser that supports Vertica syntaxes. You're thinking, okay, let's write our very own. We take what's there and we kind of tune it up. Well, that's the best case scenario. I've seen a few parser for SQL dialects. The one that I've shown you, writing mine from the ground up. Why not? Usually a lot of people write it from ground up and it's bad. That's why I recommend you to take the ready-made solutions. The bottom line is that you need parsers to work with the AST tree, right? So that it's understandable, right? Right.
Есть что абсолютно по-доброму. Пожалуйста.
Добрый день, спасибо за такой интересный
Hi, thank you.
Ну, потом кейсов использования AST дерева.
There are a lot of cases for AST trees and parsers.
Меня вот вопрос, на самом деле,
I was curious
профессиональный. Я посмотрел на
professionally.
ваши примеры NTLR. Ну, я с ним просто много лет
I
работал.
looked at your Antler examples. I've been working with it for a few years, and you've been using
Формат в виде одного
the
файла.
format like one file. Is this just a particularity of Python?
Особенность примера просто. Можно
That's
выделить
just the
отдельно токен,
example.
отдельно грамматику.
You
да.
can have a separate token, separate grammar.
Что лексеры и парсеры, они все-таки должны быть
Lexers and parsers should be separate, right?
импортировать и так далее.
So that you would be able to import them in the future. But as for the example, look,
Стат-анализ. Я просто как раз сюда
Stat
пришел
analysis.
из-за стат-анализа.
I came
Я
here
так
because of the
понимаю,
stat analysis.
лексический разбор, и он там дальше следует. То есть написание
mean,
анализаторов кода, там,
you analyze code,
Sonar или
Sonar or
записывание
whatever there
и так
is.
далее. То есть это гораздо более интересная вещь, чем просто вот
This is much more exciting than simply dealing with the SQL lexic. There are dozens of those ready-made, and it's very easy to transfer to any language.
Вот, я вижу ваше будущее.
Yep. I see your future at the coffee break,
Это
my
счастье, мы
man.
же для этого проводим как раз
That's why we're
конференцию.
here. That's why we're hosting a conference. Of course.
Здравствуйте, Билак, Райфайзенбанк.
Good luck,
Когда вы
Raiffeisenbank.
показали слайд
When you've
с
shown a
SQL,
slide with the
где хочет
SQL, where the
показать
analyst
название таблицы, дату, и
wants to show the
получить всё,
table
мне
names,
первое,
the
что пришло в
dates,
голову,
and all of
сюда
it,
можно еще
the first thing I
попробовать
thought of,
написать drop
well,
database, там
I can do the
insert
drop
данные,
database here,
что-нибудь
insert
выбрать, что-нибудь,
data,
что ему не положит.
pick
Ну ладно, с
something.
инсертом и с дропом, там,
Well, with
понятно, вы
insert
на
and drop,
уровне
it's
прав
more or less
отрежете его.
clear.
А вот селект, то,
But
что ему не положено...
As for select,
Скорее вопрос такой.
it's more of a question.
Вы как-то потом это анализируете, когда вам парсер
Have
всё
you
это
been
сделал
analyzing that
вручную,
somehow after
или
the parser
парсеру
has done
как-то
that
можно
manually,
заложить? И,
or maybe you could put it into
были
the
ли
parser
кейсы,
somehow?
когда были
And did you ever
инциденты?
have
Это
cases where you had incidents? That's even more interesting. Incidents with the analysts are always happening. If you don't have validation tests and you just allow execution of some SQL in a warehouse, not because people are evil, just because that there are many of those, and people don't always think of the things that they need to be thinking about. As I said already, the output of the parser, first and foremost, must be abstract syntactic tree or something else convenient that you will be able to work with. So you can generate SQL. We have the opposite example when we run tests. So we get some output and we check that in this output, there is not what we don't want to see there. So for example, we know that there's certain drop and we are not prohibiting that. We just want to start the method first. It will check if we drop this table, nothing else will be dropped. We have some dependencies, etc. So at the parser output, we get a result that we will be working with.
Свои кейсы были такие?
Did you have your own cases like that? Evil cases. Evil cases. When there's a lot of analytics, and the top management is looking at that, the analysts, and in the middle, we get some SQL, which has either not been executed or executed with an error. No one is seeing analytics by 10 o'clock in the morning, and everybody's kicking you in the butt.
Спасибо. Еще пару вопросов. Раз.
A couple of questions more.
Надо вверх щелкнуть там. Получилось?
Да, вроде получилось.
Супер.
Да, привет, все еще Коля, все еще душный из Litres.
Still
Спасибо
Коля.
большое за доклад.
Still from
Очень
Litres.
интересный, такой зубодробительный, я бы даже сказал. И отдельное спасибо за кучу ссылок полезных
Special
материалов.
thanks
потому что я
for
думаю, что сейчас за раз это
great,
тяжело
useful
переварить,
material.
особенно
It's
когда
hard to
вникаешь
digest
в
all
темы,
of it
но
right now, especially
явно
when you're
будем
not an
много
expert in the
возвращаться.
subject.
Вопрос такой,
But we will return to
что
this
ты можешь
definitely.
посоветовать для
What would you
погружения
recommend
в вот эту всю тему с AST? Потому
to
что вот, например,
get
если я
immersed into
хочу
this
написать там,
AST?
чтоб, ну, да, разобраться, там еще что-то, свой какой-нибудь линтер, я хочу углубиться в то, как вообще в
I wanna
разбирать у питона какие-нибудь связи между модулями, классами.
deal with
Больше не
the
про
connections within Python with
операторы,
modules and
скорее, да,
classes.
а про именно взаимосвязь.
It's
там,
not about
модулей,
operators, but
объектов,
about
вот этого
connections
всего.
between
То есть
modules
куда вообще покопать?
and objects of all of it. Where should I dig into?
Стандартное ST какое-нибудь или есть какие-то более удобные библиотечки сторонние?
Смотри, ты имеешь в виду, если тебе нужно понять, в каких модулях есть какие-то объекты, то есть тебе надо межмодульное. Я честно врать не
So,
буду, потому
I
что
will
если
be
я в
honest
основном
with you.
работаю в рамках одного модуля, то есть я могу там взять какой-то объект и по ST
I can take one object, look at the AST tree, and look at the all connections.
У тебя,
I
то есть,
think
когда у тебя строится в питоне AST-дерево,
when you build the AST tree in Python,
какие-то рандомные, у тебя, получается, есть всегда верхняя
you get
нода, которая
the
содержит в
upper
том
node
числе и
that
импорт. То
always
есть тебе надо по
contains
факту
imports.
пойти взять импорты из AST дерева этого модуля, и потом, если ты хочешь дальше по цепочке, тебе надо ходить в эти модули.
And then down the chain, you need to go to modules and load AST trees and look at them. That's the first thing that comes into mind with AST implementation. Otherwise, I cannot recommend you any tools about how this works in practice. You need to bear in mind that pure AST module in Python, as a matter of fact, that's a class. AST tree is a class. And to me, it's just easier to do it with the ASPDB debugger or just print.
По сути, брать то, что есть из коробки, и смотреть, как оно по факту работает на коде, который хочу. Спасибо.
Да, единственный момент, что по поводу AST могу заметить, AST, в отличие от языка тоже, AST
as opposed to syntax, AST changes from version to version, and with 3.7 was a huge transition to 3.8, were different nodes. So when you write different versions for Python,
добавляйте.
You need to write it. It will not work for all of the ASTs.
Да. По поводу линтера было сказано.
Встаньте, чтобы
You said a few things about linter.
Продолжить. Да, спасибо.
Посмотрите в направлении Microsoft
Look towards
протокола.
Microsoft Protocol LSP.
Как раз для, потому что парсер это все-таки у вас на одного файла.
Parser is just for one file, and then you need to process that AST here. You can just build
как раз в проекте целиком.
one tool for the project. That's it, with all dependencies, etc.
Еще была рука у вас.
There was a hand.
Вопрос, или я остался?
Have you
Ребята, давайте
forgotten the
микрофон
question?
дадим,
Guys, let's give a microphone.
И потом выбираем лучший вопрос, кому дарим сюрприз.
Хорошо.
Вот, он, смотри, машет рукой. Да, ага.
Привет. Классный
Okay.
доклад, спасибо. Вот ты привела
Great
пример
presentation.
задачки.
You gave an example of a business task. Initially, it seems that it can be just solved with the regulars
Не знаю, там,
and
select.
do something with the select.
Менеджер говорит,
But then the manager comes and says, I want to make it more complicated.
В какой момент ты понимаешь, что
So, at which point do you realize that you need to move from regulars to a more complex solution with the AST tree? Think of your parser with the regulars for the examples that were... I mean, I can show you.
Сейчас мы долистаем. Вот, например, для тех примеров, которые снизу, чтобы вот это вот все поддерживать. Ты просто начинаешь понимать, что тебе надо будет эти имена таблицы отдельно выхватывать, операторы внутри надо выхватывать.
So you need to look at the names of the tables, the operators, and then you know that probably this is not going to be an end. And probably it will be not one table, so you will need to go and clarify this. If the operator is a minus, it's not minus one table,
или, может быть, минус 3 таблицы, что-то
or minus 3 tables, and then you look at it and think, okay, probably it's easier to describe this grammar somewhere, because as a matter of fact, your language is very similar to the regulars.
Что грамматику написать.
Спасибо. И еще
Okay, thank
маленький
you.
вопросик.
And another small question.
Задача на основе описания грамматики, вот как было в примере.
Based on the grammar in your examples,
Готовый
is it possible to generate the visits? I mean,
делать, насколько я понимаю.
it seems to be
Ты
possible.
имеешь в виду... Нет, смотри, visitor
No, look.
это именно
A visitor
тот класс,
is the
если
class
в fly это, например, метод, который описывает, что делать
or a
с
method that
конкретным
describes
терминалом.
what you should be doing with the actual non-terminal. You find an expression, what do you do with it?
Ноду запихнуть или там какой-то вывод.
You put ST node into it or a conclusion.
Генерация AST нод.
In Lark, there is generation for AST nodes.
Он такой, видишь, что
for your grammar. It sees that probably we'll have these non-terminals, so I can give you AST tree right away. And yes, Lark can do that. It has a feature. In most parser generators, no.
Спасибо.
Okay,
Отлично.
thank you.
А все, кто задавал вопросы, махните
Perfect.
рукой, пожалуйста.
Everybody who asked questions, can you wave your hand? So who will get a prize? There is a problem. By the evening, my memory
Не помнишь первый вопрос?
fails. You don't remember the first question, do you?
Нафига? Хорошо, тогда мне нравится вот вопрос про когда регулярки понять.
Okay, I love the questions about the regulars.
Последний.
Так, последний.
Да.
Отлично.
Okay,
У тебя
great,
уже
thank you.
есть. Смотри, у него
So
уже
you have,
Уже есть.
you have it. He has the prize already. Okay, I get it. Then the third option,
Человек из
isn't it?
стресса тоже наверняка был уже.
У него вообще все есть.
У него все.
The dude from Litras, he has everything, I guess. So the colleagues who are dealing similar things, but in a different sphere, right? The colleagues who actually consulted all of you there.
Да, и тебе тоже памятный
Okay.
приз от конференции.
Prize from the conference to you.
Ой, это даже
Thank
не
you so
просто
much.
пакет.
Да,
It's not just a package.
это очень круто.
It's a lot.
Друзья, у
Thank you
нас
for your work. Friends,
технический
we have a
перерыв,
very
и мы
brief break,
через
and
6
we
минут
will
вернемся
return
сюда,
in 6
чтобы
minutes
послушать
to
докладчика,
listen
который
to the
закроет
presenter
сегодняшний
who
день
is
и
wrapping up
благословит нас
today.
на завтра.
And bless us for
6
tomorrow.
минут.
6 minutes.